Okay, interesting little job here that we are going to use the MR1, our gantry mill for, CNC gantry mill. These are cover plates for flush mount HVAC vents, the kind that you put in the wall and the drywall and then you mud around it, so they sort of like, hot rod guys would call that Frenching, where you make like the headlights and the taillights disappear into the bodywork. Sort of the same premise. You know, traditionally they look like this. You just have like a vent register that's just applied, and it, you know, looks like what it looks. This is sort of the bougie version, but they're having airflow issues at the customer's house. So Jack, of course, over at Hamlin Builders, brought these to us and sort of sketched what he thinks would work well. I think basically just a slot milled in the face of this with some connecting pieces, of course, so the middle part doesn't fall in. We've already done a test on one of the plastic ones. Here's some of that footage and those photos here. It came out pretty good. But these are metal. So we have 1, 2, 3, 4, 5, 6 plastic ones, which is the only one I've technically tested. And then we have these 4 bent steel ones. They're 0.04, so a little below a 16th, probably 18 gauge steel. And the idea is to just cut, basically we're cutting 4 L-shaped Tetris pieces out of here, leaving 4 connectors. So I'll show you guys what the programming looks like on the Fusion side. I just learned some new tricks this morning, and then we will go out to the MR1, test one of the metal ones so that I understand both materials, and then we'll just set it up and go.
When you're cutting the plastic versus the metal, is there a real difference in how you program the mill?
Yeah. So I printed this off. This was from Langmuir's website. This red box and chart is non-ferrous metal, which non-ferrous is everything non-magnetic. Ferrous implies magnetism. So aluminum, brass, bronze, copper, plastic, you know, all that stuff. That is done with a 2-flute end mill, whereas ferrous material, at least softer ferrous material, is done with a 4-flute carbide end mill. 4 flutes, you know, the drill bit, the flutes are well, they're flutes.
Edges?
They're the troughs that go down the bit. And the more flutes you have, the more cutting surfaces you have. But less flutes means more room to clear chips. So it works out, less flutes for aluminum. You have more space in between the cutting edges for those big chips to evacuate the hull. So we'll be using an 1/8 inch end mill for both so that we have the tightest corner, you know, geometry. Spindle speed is 8,000 RPM for both. Feed rate is 15 to 30 inches per minute for both. So that's the same. Depth of cut for steel, you're only looking at 0.075. For non-ferrous, you're looking at almost an inch, 0.125. So that's one of the first big differences. For steel, you're gonna hog out less material. You have an 1/8 of an inch depth there and a little over a 1/16 here. And then width of cut is similar. You've got 0.03, basically a 32nd, and then 0.02, even less than that. So you take these settings from this chart, and when you're programming your stuff on Fusion, you want to take these in and double check it against the suggested settings. I will say, Fusion, at least when it comes to the MR1, Fusion is really generous with cut speed and cut depth. It's kind of aggressive, so you want to definitely make sure that you're going in and fine tuning based on this. So that's the ethos, the thought behind it. And again, we've already done the plastic part. Either you've already seen that or you're gonna see that right now. And welcome back from seeing the plastic part. Now it's time to do the steel part. Let's jump over to the computer. I'll show you how to program all this stuff. So this is the plastic version of the HVAC vent. And if you look, it'll look a lot like the metal version. So they're just different sizes, and so I just made I made the parts in Fusion. I didn't do it, you know, the fancy way. I didn't use sheet metal tab or anything. I just made a face, you know, I made this sketch, and then I drew an offset, you know, just did an offset sketch, the thickness of the wall of the part. This is the metal one, so it's very thin. And then just extruded that down. It's not even really necessary for the sake of programming this or the machining as far as the computer is concerned. But being that recreating the part one-to-one was really easy, it was just one extra step. I went ahead and did it, just in case it was relevant down the road. But so here's the part this is the end product that I want. I made the connecting pieces a little bit thicker, just to mitigate any sort of issues with the centerpiece here falling out or whatever. Just a little bit more meat to hold it, but still plenty of open space so that the airflow is increased. Because that's what we're after. When you an HVAC, when you shut down a bunch of your vents or if the filter's clogged, any restriction that the air has, it's going to make noise. The sound of that air trying to force its way through a small opening will make noise. So this brand new house they built, they put all these vents in, and the HVAC guy was like, you know, not only is there not a whole lot of airflow to achieve, you know, the desired result with cooling or heating the house, but the air forcing its way through these really restricted vents was making a lot of noise. These are the parts. So let's start with this plastic one. So once you have your part made, this is everything I've come to learn about post-processing, you know, programming for 3D machining, CNC machining in Autodesk Fusion. So once you have the part, you come up here where it says design and you jump down to the manufacture area. And nothing really changes when you jump over here. But the first thing you do is a setup. So I already have a setup, but when you do it, you come up here and you click new setup. So what the setup's main job is to define the stock or the raw material that you're cutting your part out of. In this case, the piece that I have, the vent part, is the stock, and there's no extra stock. You know, normally if you're taking a giant block of aluminum and you're making a part by machining a lot of it away, your stock may be a lot bigger than your finished part because you're removing a bunch of material and you want a little bit of extra here and there. In this case, the stock is the material. So when you go over here to stock, I click relative sized box, which means the box that it's going to assign as the stock is relative to the size of the part. And then I just make sure that all these offsets are 0. You know, if I were to increase this 0.25 top offset, you can now see this lighter yellow part here is the, you know, it's expecting that to be the material. And then if this, so if this were true, if I wanted to mill that 1/4 inch away and then cut the slots, the first process I would do would be like a roughing pass or a facing pass to mill that stock off and then cut my contours. But I don't have to do that. I don't want to do that. That's not what's happening. So I'm just going to put this back to 0. So my stock is the part. And then the only other thing I need to do is make sure my origin is in the right spot. So I know that I'm clamping the part in the MR1 sideways like this, and the MR1 has an away from you is Y positive and to the right is X positive. So I'm checking my origin here against what I know to be true in the machine. So that all works. That's all I really need to do here. It's all that's really relevant to what I'm doing. I don't need to select the machine or anything at this point for this to work. So you hit OK. So you have your part set up, your stock set up. Now we need to mill our slots. And if you're cutting a slot, or either you're milling a slot into a block that will have a bottom. The slot will have a bottom face. In this case, I'm milling a slot through something. So the setup is the same, it's just the settings are a little different. So what I've chosen to do up here is a 2D contour. So the 2D contour, let's see, I'm just gonna delete this and show you in real time. So I've done my setup, I have nothing else. So now I go up here to 2D contour and work left to right. So the first thing I'm gonna do is pick my tool. So for my Langmuir machine, I have all the bits and everything from Langmuir loaded into my library, my local MR1 tool library. You can get this from Langmuir on their website. Very helpful. Just go to the MR1 page and go down to like downloads. So this is the small plastic one. So what I'm going to use is the non-ferrous aluminum slotting. It's a 2 flute. So here, number of flutes, 2. It's carbide, flat end mill. It's not a rounded end mill, it's flat. So I'm going to select this tool. And so you start there. You can see it sort of renders a ghost tool holder right here. And it's just sitting on the origin. So the next thing, let's see, plastic slotting. So the next thing, excuse me one second, grab one of my parts here. Next thing is to take the info from this cutting parameters chart from Langmuir and enter everything. So spindle speed, from this preset number, I have to change it because our spindle cannot turn 12,000 RPM. It is locked at 8,000. So put in 8,000 and let's see, non-ferrous slotting, contouring, 1/8 inch end mill. All right, feed rate 15 to 30. I'm gonna put it at 15. I'm gonna put it at the low end of the range because these are sensitive parts. I can't afford to screw them up. Slower is fine. Now lead in and lead out, you usually want those to be a fraction of your cutting. So I'm gonna go ahead and just do 7, which is basically half. Transition, I know that needs to be lower. I'm doing this because of a video I watched. I can't remember, there was percentages, you know, these lead in, transition feed rate, plunge feed rate, you want them to be a percentage of your full-on cutting feed rate for safety. So basically half or a third, kind of, and that's all you really need to touch on this one. I do not want coolant because this is plastic and I don't need it. And I don't want to soak the part in coolant. Next, we go over to geometry. So this is the important part. This is where you tell the program what aspects of the part should I pay attention to when I'm designing this toolpath. And so I'm just cutting a slot. So I'm gonna pick the bottom edge. You can see here, you've got the top edge and the bottom edge. I'm gonna pick the bottom edge of all of these slots. Boom, 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 boom. Okay, just like that. And I'm going to, so that's all I needed to do. For my heights, so the heights tab shows you when the machine does certain operations, it tells you what heights it does those operations at. So you have your retract height, you have your feed height, you have your clearance height, and the top of your part, or what it will recognize as the top of your part. So when it's feeding over, I'm not exactly sure what feed means, but retract and feed are basically the same. So when it's not cutting and when it's moving from one operation to the other, it will retract up to this height of a 1/4 inch above. It will feed over at that height, and then it will come back down into the material when it's ready to do the next operation. The only thing I'm going to add here is the bottom height. So I'm going to pick, so for the bottom height, I'm going to pick the top height for reference, and then I'm just going to go minus 0.0625. I'm going to, oh, this is plastic and it's thicker, so I'm just going to do an eighth, 0.125. And now, I mean, technically, if I wanted to get really accurate, I could just measure the wall thickness. The wall thickness of this is 0.105. So if I put the bottom height at 0.105, there's a chance that in a certain area or a few areas, it may not cut all the way through. Again, I'm trying to cut completely through the top surface of this. I'm going to do more than 0.105. I'm going to go minus 0.1, just call it 15. So 10 thousandths more than the theoretical bottom. I think that when I did the test piece, I did it at -1/8, but this is machining, CNC machining. Let's get nice and precise. All right, that's all you need to do here. And again, you go to your side view just to idiot check yourself. You can see how all the heights are stacked up, making sure everything's kosher. And now we go over to passes. Now, passes is a really good tab because you can fine tune a lot of this stuff. So for starters, you can change it from climb milling to conventional milling. I'm just going to read this for you. You know, climb milling can be thought of as the cutter rolling along the surface that it's cutting. This generally gives a better finish in most metals, but requires good machine rigidity. Using this method, chips start at a maximum thickness and get thinner towards the end of the cut, meaning more heat in the chip and less in the part. With conventional milling, the cutter is rotating away from the surface it is cutting. This method is more commonly used with manual or less rigid machines. It does have some advantages and can even give a better finish when machining certain materials, including some wood. Yeah, router bits are almost, it's really dangerous to use a router and use climb milling. You always want to be cutting against the direction of movement. So with that said, softer stuff, let's do conventional milling, which means we're pushing against. So right here, from what I can see, because the machine is going to be rotating clockwise, and it looks like the direction of movement is such, you can see these little arrows here. It looks like this is climb cutting. So I'm going to go to right offset. So I'm going to leave it at that. No finishing passes because I just want to cut. Oh, you know what? I may do multiple passes. So I'll cut this in a few depths. Do multiple depths here. I'm going to do a little bit of overlap. I'm going to do an 1/8 inch of overlap. Maximum roughing step down. So you can actually get the step down value from the chart here. So depth of cut is the step down. This has it at like 0.3. I'm going to put 0.0625, 1/16 of an inch, which is half of the rated step down. Finishing step downs. Approach mode specifies how to approach along a tapered wall. There's even a thin wall milling option. Very cool. All right, so finishing step down. Let's do one finishing step down. Okay, now the last thing is linking. So linking, the only thing I do on this page is you can change your lead in and lead out position. So prefer lead in position, I'm going to pick on the side, and preferred exit position also on the side, and hit OK. And now it will generate everything. So you can see here, because it thinks this is a solid stock, the key thing to look at is right here. So if you look at the corner, right? You see how I hover over this corner and that line doesn't go all the way down, doesn't cover this bottom section? That represents the thickness of the stock. See, when I click on it? So this, because there's more material below that line, it tells me that I will be in fact cutting all the way through the top surface of this part. So you can see there's a few finishing passes and whatnot. So yeah, it looks like it cuts into this wasted material in the middle. I don't know why these are in the middle and this is in the corner, but it doesn't really matter. It's all going to be fine. So why does this have a problem? Some exit positions are unusable. All right, let's go back to linking. I'm just going to let it pick on its own. I don't think it really matters. All right, and so that is how you cut through a material and you cut the outer contour of a slot. So I know that was long-winded, but for the people that wanted every step of the operation, there it is. If you don't want to see the whole thing, just click through the video like you probably do already. And then over here in the down right corner, it shows you the machining time. So this cut will take almost 8 minutes, which is good because the first iteration I had for doing this, it was a way longer program and I was way overcomplicating it because it was doing this weird like spiral stock removal thing, which you've already seen, or we already filmed that part, the like first test. Okay, so that's the plastic one. And now all I'm gonna do is the same thing on this metal one, but you know, changing certain feeds and speeds and heights because it's a thinner material and it's harder and blah, blah, blah. So that is how you do the machining, the programming for a slot. So I'm gonna do this next one, and then the next thing you'll see me do is cut pieces of wood to go in here to keep these walls from being squeezed together by the vise in the machine. But that'll be in a second. I'll see you guys in just a second. All right, it's time to leave the safety and warmth of the office and step out here to the shop. Over here to the MR1, I've turned the spindle and the control switch on down there. There's still left from the original plastic milling. Figure I'll just do all the plastic ones and generate all the plastic mess and then clean that up, and then I'll come back and do everything else. So over here, this is the computer screen with the MR1. Open cut control, and this sweet touch screen. I already put my files, my programs on this cool little Shop Saver pen drive. If you buy a Shop Saver plasma table, you get one of these. It's just the only pen drive I had laying around. So cut control will open. First thing you do is home the machine. So home. Still got my 1/8 inch end mill in there from last time. It'll find its Z parameter. Okay, now it's homed. And now when I press my buttons, it'll move. A handy button on the cut control is this send to front button. If you press that and hit continue, it'll bring the whole thing forward. So if you need to change your bit or do any of that, that's a good button to press so it comes forward so you can work on it. But I'm actually gonna send it to the back, get it out of the way of the vise so I can mount my parts. Got this leftover piece of 3/4 inch plywood, and it's got 2 screws in it. I'll try to get those screws out. Got my handy dandy little Craftsman Sears table saw. Crank my blade up high enough. All right, so for starters, got the grain of the wood going this way. That's the side I would like to resist the clamping. So that's gonna be my width, 4 inch. Length is gonna go this way. Start by giving myself a clean edge here. Now, the first width I wanna cut is 2.775. I have never once set up the fence of a table saw using calipers. Whoops. Wait till it stops, Tay. Wait till it stops. All right, so 2.775 right there. Lock that in. Break my fence loose. Tap it over. These fences are terrible. That should work. Okay, so here's what I'm doing. That will fit inside there, as it does, nice and tight. So when I set this in the vise, in the machine, and I clamp the crap out of it, and I start removing material from this top face, these sides, and nothing buckles or moves because I'm still held in like that. So that actually worked perfectly. So that's for the metal grate. And now I need to adjust this to 2.4 inches for the plastic grate. Yeah, perfect. It's too long, but that's the fit. Yeah, that's great. Fits really good. Now I just gotta cut them to length. The respective pieces, and we'll have our spacers. It's cutting to 4 inches because the vise jaws are 4 inches, so it's There's no real need to cut more than that. This one I'm going to leave a little more meat on there just because I can cut the screw off. There are our anti-squeeze devices. All right, so my job now is to make this repeatable. And what I'd like to do, I'd like to get the surface of this up above the lip of the vise like this so that we don't have any collision issues. And so I'm going to use these parallels from Langmuir. Any machinist knows what these are. These are two pieces of steel that are precision ground to be parallel. So both of these are the same height, and I've got a whole box of them. So I'm going to set these in here. This will sit on that, like so. Now, the other thing I want to do is make a stop somewhere so that I can take this piece out and bring the next piece in and rest it against the stop, whichever side it's going to be on, so that I can just crank through these instead of having to zero the side and find this 0 point by the hard way every time. So the way I'm going to do that is use these step blocks, Mr. Spikes, and build them up so that they're tall enough to hold this guy.
This. So your zero will be the same for everything.
That is correct. Can you thread that stud down?
And so this needs to make sure that it's up against there.
It doesn't right now because I haven't zeroed anything.
Oh, okay.
It just needs to stop. Yeah, I've got my parallels under here. You know, all they need to do is hold it up a certain amount. So then, got my piece of wood that fits nice and tight. So that drops in there, that goes to there, and that clamps on there. Now the wood will be milled into, yes, but it does not matter. The thickness is 0.105. I'm cutting to a depth of 0.115. I'm only going past the surface 10 thousandths of an inch. Cool. So just bare minimum, just enough to do it. All right, so I'm gonna make you zero it this time. Aren't you excited?
Yeah. Yeah, I actually am.
I'm gonna make Spike zero it this time so he understands the concept, and there's one more person in this shop that knows how to do this. Yeah. So just get acclimated. So again, first thing, where's your tool?
My tool?
Look at it. Just
it's there.
Just look, you know, compare your tool to the obstacles around.
So right now, if I move on the XY axis, I'll be fine.
You're good. So these buttons, yep, you just freely move it around.
Yeah.
Yep, and you've got your Z plunge. This is in there from last time, so there's no tool needs to be done. Also, familiarize yourself with this pendant. So the same controls are available. You have your D-pad, which moves, and then you have your Z as the page up and page down there. So I would rough it. Here, move this out of your way. I would rough it, and then once you get close, I would slow your travel speed down.
Okay.
So on your screen, you see, so you have two pages. You have step and you have speed. Because you're going to leave this on continuous, you just change your speed. So yeah, 10 inches per minute is fine. So now you'll move this out of your way.
I can see it right here. All right, so I'm noted that I'm not close to it. I can see it in the 3D space.
But now you can see you're a lot slower. Just like the plasma, X positive, moreover, is that way. Y positive.
So I'm close to it right now.
Right. So you want to. Here's how I choose to do it. So I would get it below your grade about 1/8 of an inch or so, pretty much your cutting depth. So I'd come down a little bit. Yep.
All right.
And you want to make sure you're well into that side face. So go that way. Just a little bit. Yep.
So now,
this is the part. So he just made a witness mark on the Y direction. So it just can't, the 1/8 inch end mill made contact, and we want to tell this thing
0, right?
So you don't have to zero it. You can just go ahead and do directly your negative offset. You don't zero it. Yeah, click your number.
Oh, okay.
Same thing. Minus.
Negative 0.0625.
Yep.
Okay. And now I need to go up. Well,
yeah, when in doubt, Z up.
okay.
And you're still on your,
Right.
you can go rapid continuous, so continuous
So I'm
rapid.
going this way.
Yeah, just make sure.
Yeah. And then just to make sure.
When it comes to rapiding off of a 0 point, I would always just Z up first, just in case you get that wrong. Now you're up in the air, and so now hit go XY, and then, then you just do your idiot check. Just look in there and make sure you're in, it looks like you're in the right neighborhood. You want to do Z now?
No, I'm just like getting, just kind of lining it up.
Yeah.
So if I'm being perfect, it looks like I need to come over that way just a touch, but that looks pretty good.
Yeah.
Especially for this particular. Yeah. Okay. So now I'm doing the same thing with Z now.
Yep. So turn your spindle back on,
Okay.
and
I'm gonna go.
you can. Well, you're at that's not going to get you far, and then leave it on continuous.
Yep.
And just go over kind of a 1/2 inch, get it well on that surface. In fact, if you can imagine where the cutout's going to be, it's always better to do that, which is basically 1/2 inch over, 1/2 inch up, or like 5/8 over, 5/8 up-ish. Yeah, somewhere in there.
Right there.
Yeah, something like that. Yep. So I would. So now with the Z, you do absolute 0.
So 0.
Yep.
Okay.
You're good.
And now up.
Yeah, but you're rapid and continuous. Your Z up first. Yep. So now you should be ready to run the program. You've got your XY 0. Our part is up against our stop.
Okay, so I'm gonna do XY 0.
Yep.
Just because I'm.
Yep.
All right.
Now, if this was a multi-tool job, the next thing you would do is calibrate your tool probe, your tool setting probe, so that your Z0, basically what that does is it establishes the distance between your Z0 and the top of that probe. So 2 known surfaces. So then when you go to change tool, you hit the calibrate button, it goes down and touches that probe, and that tells it exactly how far away the tip of that tool is from your Z0.
How does that work?
Yeah, so now what you would do is make sure your Z is up, always Z up. And then over here you have touch probe and tool setter. That is the tool setter. So turn that on. We can just do it. And then you have 2 choices, calibrate and auto tool set. We want to calibrate the tool. So just hit calibrate, and it's going to say, I'm going to move to the left this far and back that far. And I've already located the probe in the machine. So you just hit continue. And so it rapids over, and then it comes down and touches the probe. And it'll do one quick, and then do another fine touch. And that's it. So now you're calibrated. See, now the tool offset value has been calculated and stored for future auto tool change routines. So you hit OK, and then now you're free to mill. You do your first operation. And then if you were to say, take that out and put a drill bit in, you come over here to auto tool set, which we can do it with this. It doesn't matter. Let's say there's that send to front button. Click that, or let's see, let's go up first. Click that, as if you were gonna change the tool. It's gonna say, do this, yep, continue. It goes up anyway, brings it to the front. It's just sort of working through the workflow.
Right.
So you can change your tool, use your wrenches, take it off. All right, let's say you just put that tool in. Now you just hit auto tool set.
This one?
Yep. And you hit continue. And then it goes back. And then it goes down.
I'm gonna do a quick one and then a fine one.
Yeah.
Fascinating. That is super helpful.
Isn't that cool? Yeah, because doing that, then you'd have to do a manual Z offset every time without that. So now you're set, and if that were tool number 2, you're ready to just do your second operation.
Cool.
So now I would just say put it pretty high over here somewhere, and I think it's time to load the program. Or you can hit go XY as another test. Yep. Rapids over. That's a great starting point. So let me go get the flash drive. Oh, there's a flash drive.
Flash drive down.
So unfold that and plug it in. I have this USB hub over here.
Did you do it right the first time? Yes.
Nice. Damn, he gets.
I know.
You remember those Most Interesting Man in the World commercials?
Yeah.
Spike, yours would be USB slots have to do him 3 times to get it right or something.
Yeah.
Okay, so you put your program in, now you load it. So you go over up here to that gray box. Yep, and then I've created folders. So this is Fink's HVAC. You just double tap. And then this is, so plastic test was what we did the other day. I have plastic vent cut 1. Okay, and then this is another opportunity for an idiot check. So this is your origin. These are where the cuts are happening. So it's another quick reference, like, is that what I want to happen?
Right.
Coolant has been disabled, but
Where do you see that?
I did it in the programming. So that would be your coolant test button if you wanted to purge the system or whatever. But it's still worth, when you hit start, you could cheat it by making your start point way over here. And so when you hit start, if there's coolant involved, if you hit start, it should start pumping immediately. So if you hit start right now, you hear no coolant trying to pump. So good quick little test to make sure that I actually did disable the coolant. So
Now, if it weren't disabled, can I disable it here? Do I have to go through the
you have to go back there, I think. Or really, you could just unplug the pump down there. So I think we're ready to do our plastic cut. I know. Well, now it's out of your hands, and now it's actually back in my yard.
I did good.
Yeah. But yeah, go ahead and hit start, and let's see what happens. Let's see if I destroy a bit.
Yeah, this one's definitely a little bit higher.
Yeah. See our run time down here. 7.5 minutes.
Cool.
Nice.
All right, so now I want to Z up.
Yep, when in doubt, Z up. Yeah, that thing goes to sleep, so it wakes up.
Okay.
All right, and I would just push it over to the left, out of the way, as long as you get access to everything. All right. Now I should have taken that out, probably bad practice, but your tool's sitting right there, so give her a crack.
Lefty loosey.
Yep. Oh, it looks like we left a little flashing in there.
Yeah.
So I should probably change that file to cut a little deeper, because there's no reason why we can't cut into the wood a little bit.
Oh, I mean, but it's film.
Yeah, just got to take a utility
File.
knife here. Yeah, I was trying to get fancy. Nice. Yep.
Cool.
Cool. You want to run another one?
Sure.
From start to finish?
Sure.
Good practice. When there's when you have repetitive things to do, it helps you practice a lot.
Yeah.
So first thing I would do is blow take your parallels off your vise. You know, one thing we could do, so to correct the flashing, you could do one of two things. You could go change a cut file or cheat your Z-axis.
Yeah.
So
Yeah.
it's probably best to just leave it a little bit like that.
Yeah.
So go grab another one.
The power with the laser, the power is, it says it's capable of scoring paper,
Yeah.
which is bonkers. But
What, this thing?
Yeah.
This?
You can score paper with that. Like,
Oh, wow.
I think it's just a wild.
Which is
thing to
just
say.
turning it all the way down and just
Yeah.
like cutting through.
We can make like the best paper airplane ever.
Oh, sick. That's actually really cool.
Yeah. But I think about that with the mill. It's like you could bring down a piece of, material down so it's just like a
Paper thin.
thousandth of an inch thick.
Yeah.
All right. So I have this. A
Yep.
block of wood is in here.
Clean your block off.
Yeah, I'll clean your block off, kid. All right. So I put it in the wood.
Yeah, and I just made the block 4 inches, which is basically the same size as.
Yeah, okay. So now, I'm talking this out for video and myself. I'm gonna put it in here.
Yeah.
And bump it up against there.
So the 2 control surfaces you want to reference right now are your stationary jaw and your stop.
All right.
Okay.
So everything feels right.
And you can tighten it as much as you can by hand.
Yeah.
And before you put the wrench on it, just one more push straight down, flat. Yep, just to make sure that's your most important metric, is to make sure it's not rising out of the jaws.
Okay.
Okay.
So then I just give it a little twist.
Yeah, and this is where you just kind of use your best judgment, you know, just nice little tight. Let me check. Just so my, you can go a little more than that. Okay. Yeah. My calibrated elbow torque wrench. Yeah. And that's all you should have to do.
All right, so if I want to be idiot proof it, I go to XY.
Yeah.
Just to see if it.
Yeah, and you could bring it down. It's probably good. Bring it all the way down and just make sure that your XY looks pretty consistent. Pretty damn good to me.
Cool.
All right, and this side. Yeah. I mean, good enough for HVAC vents. Yeah.
So now,
I don't know why, but I've gotten in the habit of just Zing up.
Okay.
Just in case.
Just in case, you're right, because the first move it makes.
Yeah, you never know. And then you're still loaded.
Plastic vents open.
Yep. You should just hit start.
Start.
And it's like it's coming down full speed, so you're like, ah! Now we're literally already making our second part. Cool. So once you do all that setup, that's the deal with CNC. Once you do all that setup, and if you have repetitive parts, that's when it starts to pay for itself. That's when it starts to really become beneficial.
So if anybody needs 100 parts that can be milled at, just let us know.
Yeah. No, please. Honestly.
Yeah.
Prototypes, limited runs, 10, 20, 50, 100. You know, this is the kind of machine that's good for that. Also, if you're looking to make them yourselves, this should be a pretty good, use case commercial for the MR1.
Hey, Tay, just to have you on video, can I make board game stuff on this?
If you film it, then yes.
All right. You heard it.
I mean, now you know how to do it. And when you go to make your parts, I'm happy to audit your programming.
Yeah, well, I'm going to need a walkthrough on that as well.
Yeah. Well, watch the video I just made and you'll figure it out.
I will. I'm going to see what part I'm in. Yeah. Wait a minute.
Here's the aftermath of the plastic milling. It's all over. I'm going to clean this up a little bit and get ready for the metal side. We don't really have any beauty shots for the end of this one because it was sort of a rush job for Jack. So he took them, they installed them. What happened once they got back to the client's house is they cleaned them, they snapped them in place, and then the painters, paint the wall and just paint right over them. So they get blended into the rest of the wall. But we've been back several times. I forgot to get final footage. Jack is a very busy man, so I don't expect him to help us get final footage. You're just gonna have to take our word for it. I have seen them, they look great. The whole point of these types of vents is to blend into the wall so you can get air circulating around the house without seeing these big ass air registers in the walls or the ceiling. So client's great. Client has given us a lot of other projects and it's a really cool house. So I learned that I do not like milling really thin metal because I broke several bits. Pretty sure I broke I broke that one, and I broke that one. And it was because when that last cut was being made, the remnant would like flip up and you get caught. And these are very hard steel, these tools, these cutters. So hard means brittle in the metal world, so they snap. I've cracked one of these by just dropping it 6 inches on the steel platform, so they're very brittle. Thank you very much for watching this. I hope you learned something about milling. If you're also starting your 3-axis milling journey, it's good to have you along. If you're a pro, and many pros have reached out and dropped their 2 cents in the comments, some of which I've actually DM'd with directly. Thank you for your input. Dump all your brain juice down in the comments. We'd love to soak it up. And I have a long way to go with this machine. This isn't what we do. It just helps us do what we do, you know? So it's a great problem solver here in the shop. I would still not call myself a machinist, but I can do some machining. I'm really a welder. So obviously check out the MR1 and LangmuirSystems.com. We love ours. They make a bunch of other cool stuff. And the tooling's actually very affordable. I've stocked up on tooling since because I know myself, and I am going to break many more tools.
Yeah. It won't be the first, it won't be the last.
Also join Langmuir's email list. They didn't tell me to say this, and this isn't on a script or anything, but like they have things on sale all the time. They have like every government holiday that exists, you'll get an email from Langmuir saying Arbor Day sale or whatever. Yeah. And like honestly, because this type of thing is very expensive, it couldn't hurt.
Neil Patrick Harris Day?
Yeah. Leif Erikson Day. Also, right now at liftarcstudios.com, all of our merch is like 50% off. What? Spring cleaning. We're trying to get our old designs out, which we do like, but I want to make some room in the office for some new designs. So everything is half off. The code applies automatically in the cart. There's no quantity limit. Help us get rid of these shirts. And it runs from now until my 32nd birthday on April 16th. So that's what I want for my birthday, is for you guys to buy all of our shirts.
Happy Take Whiteside Day sale.
But literally they're 15 bucks a piece. So show me another YouTuber that's selling merch for 15 bucks a piece right now. I'll wait.
Yeah.
Anyway, thank you. That also helps us, obviously, so we appreciate your support. We're having fun here, and on to the next job. Please like and subscribe. Thank you very much for watching, and I'll see you next time I decide to break some bits. Bye.